Modulo arithmetic is all about the remainder you get after you do the division. For example, if you take, let's take, for example, 5 mod 2. What we're looking at here is really going 5 divided by 2, which you should all know gives you 2 with a remainder of 1. So the key thing here, the one that we're looking at here, is that remainder. It's the remainder that we're after each time with mod. So we can say here that 5 mod 2 is equal to 1. So the answer in this case, 5 mod 2, has an answer of 1. We've only really got two possible solutions then in mod 2. We have, if it's a factor of 2, which is most numbers, all even numbers, you're going to have a remainder of 3, so you'd have a residue we'd call of 0, nothing left. Or if you do have a remainder, you're only going to have a remainder of 1. So the residues of mod 2 are 0 and 1. Let's now have a look at 43 mod 5. So as we talked about previously, it's all about what's remainder, what's left over after you do the division in whole number terms. So if we do this division, we go for 43 divided by 5 equals 8 with a remainder of 3. Alright, remembering the key term we're after here is the 3. So that means that therefore 43 mod 5 is just equal to 3. Let's take a closer look at another mod. Let's have a look at mod 4. No matter what solution you do, you're always going to get the same 3 answers, or the same 4 answers in mod 4. You'll either have no remainder, or you have 1 remainder, or you can get 2 remainders, or you get 3. They're the only 4 possible outcomes you can get in a mod application, okay, in this particular mod 4. So these 4 numbers are what we'd call the residues for mod 4. If I asked a typical question like list congruent, remembering congruent numbers just mean the same numbers, to 5 in mod 4. Well, what is 5 in mod 4? 5 in mod 4, when you divide by 5, when you go 5 divided by 4, it gives you a remainder of 1, so that actually has an answer of 1. So we're looking for any other number that when divided by 4 gives you a remainder of 1. So some examples might be, let's say the next one up would be 9, because 9 divided by 4. So 9 divided by 4 gives you 2 with a remainder of 1. So we could say that 5 mod 4 and 9 mod 4 are congruent. And remembering from last year, from when you were working on your triangles, the symbol for congruent is the 3 parallel lines. Okay, it means equivalent to. So have a think now. I want you to come up with at least 4 other numbers that are equivalent, that are congruent to 5 mod 4. Okay guys, hopefully you've all finished successfully questions 1 and 2 from exercise 4a. The next step we want to talk about in modulo arithmetic is a caley table, and you just need to understand that when you're using modulo arithmetic, it's like any operation. you can do an operation before it and then do the modulo operation after it. So typical applications are you might do an addition and then perform the modulo, or you might perform a multiplication and then do the modulo. So in this example, let's have a look at a caley table of well, let's take an easy one. Let's look at mod 3. Okay, and to do a caley table, we list all the residuals, the residues. So the residues, what's left over when you're doing mod 3? Well, we're going to look at, you could get none left over, you could get 1 left over, or you could have 2 left over. So we list the residues down across the top row and down the column. Now in this particular exercise, let's have a look at multiplication. Alright, and we have to fill out each one of these positions right the way across. So what you need to do is you do the multiplication first and then perform the mod operation after that. So we'll have a look at this. Let's have a go at, well, this one down here. This position down here, what does it mean? Well, we're doing multiplication, so we're going 2 times 2, getting our answer, and then going mod 3. So 2 times 2 gives you 4, so we're looking to the answer from 4 mod 3. Well, 4 divided by 3 gives you 1, remainder 1. The key here is the remainder, so the remainder of 1. So this position in here, the 0.22, has in a caley table a remainder of 1. So in this particular mod, the mod 3. Filling it in from there, guys. So coming down the row, looking at 1, 2, so you go 2 times 1. Well, 2 times 1 is, well guys, hopefully you said 2. Okay, 2 times 1 is 2. 2 mod 3 gives you 2, so that would be an answer of 2. Working our way down the first column, 0 times 0 gives you 0. 0 mod 3, well there's no remainder, so it's 0. 1 times 0 gives you 0. 0 mod 3 again gives you 0. 2 times 0 gives you 0. 0 mod 3 gives you 0. So top rows and the first column is going to be 0. Let's have a look at the other two positions that we haven't filled in yet. So we're looking at these two positions now. 1 times 1 gives you 1. And then 1 mod 3, well, that gives you a remainder of 1, so that actually has a position of 1. And 1 times 2, well, that has, 1 times 2 is 2, 2 mod 3 gives you 2. So that's a caley table for multiplication in mod 3. Right, key here, guys, is that across the top and down the side, you have your residuals, sorry, and then you perform the actual operation, whatever it is that's been indicated in the top left hand corner. Then once you get your answer to that, you do your mod whatever. Okay, let's do one more example of this, of an addition.